Okay, so let's move on to section 2.2. So here we are going to look at another way of writing vectors in 3 dimensions. So one way is using the vertical notation, another way is by using IJK notation, so horizontal notation. So vector I is simply your vector, your unit vector in the direction of the x-axis. So if you draw that, your y-axis, x-axis, and there is your z-axis. One vector of length 1 acting along the x-axis is simply called I. Vector of unit of length 1 acting along the y-axis is called J, and a vector acting along the z-axis that has a length of 1 is called K. So column notation, vector I is 1, 0, 0, J is 0, 1, 0, K is 0, 0, 1. So if you've got a general vector PQR, PI plus QJ plus RK, so this is the vector that is a point with the coordinates P, Q, R, the position vector of that point, if this is the origin, can be written as PQR vertically or horizontally, like this. So let's have a look at question 4. We've got to express the position vectors in IJK notation. So vector OA is simply take these coordinates. I need to go 1 along the x-axis, so it's 1I plus 5J, because 5 units along the y-axis, and then minus 2 along the z-axis, so it's minus 2K. OB is going to be simply 0I, I don't need to write it, minus 3J plus 7K. I quite like to write it as column vectors. In fact, I prefer this notation because if there is any element is equal to 0, it's quite obvious. So vector AB, I've already shown you, it's simply end minus beginning, so OB minus OA. So you go from A to B. So what do you do to this number to get to that number? You take away 1. What do you do? So let's just see whether it's, we'll check in a second. What do you do to 5 to get to minus 3? You're going down 8. And from minus 2 up to 7, you're going to go up 9. So I think AB is going to be this vector. Let's just check. We are going to write them in column vectors. I do encourage you to do that when you are especially working out any combinations of vectors. It's going to be nice and easy. So it's 0 take away 1, it's minus 1, minus 3 take away 5 is minus 8, 7 take away negative 2, so it's 7 add 2 is going to give you 9. And then you can write it in the required form, minus 1I minus 8J plus 9K. Okay, remember from last year, a unit vector is a vector that acts along any given vector but has got length 1. So this is the notation for that, like a little hat. So that means you have to take the vector that you have and you need to divide it by its length. That's the definition of the unit vector. So if we are asked to find the unit vector in the direction of vector A, I just need to find the length of that vector. So I'll do 2 squared, add 1 squared, add 4 squared, square rooted. So that's going to be square root of 21. And then I just need to take vector A. So 2I minus j plus 4k and divide it by its length. So you could write it as 2 over root 21I minus 1 over root 21 j plus 4 over root 21k. Or you can write it as a column vector. Now, is, oh, okay, so it's clearly, that's it for example 6. Oh, I think I've missed example 5, so let me go back to example 5. So first of all, you can also find combinations of vectors. So remember, if you've got 4a, it just means 4 lots of every component. So you just do 4 times 2 minus 3, 5. Add vector b, so 4 minus 2, 0. So just go along the top entries. So it's 4 times 2, add 4. Then you go along the middle entries, 4 times minus 3, add negative 2, so minus 2, and then 4 times 5, add 0, needs to be calculated. So it's 8, add 4, which is 12, minus 12 minus 2, which is minus 14, and then 20. This is vector 4a plus b. Okay, doing this one, 2a minus 3b is going to be 2 times a, so 2 minus 3, 5, minus 3 times b. So I'll do this one a bit quicker, but obviously you could write it as a combined version. So 2 times 2, which is 4, minus 12, 2 times minus 3, so it's minus 6, add 6, and 10 minus 0. Okay, so this is going to be 4, take away 12, so it's minus 8, minus 6, add 6 is 0, 10 minus 0 is 10. Now, is any of these vectors parallel to 4j minus 5k? Let's write this as a column vector, so 0, 4, and minus 5. So I can see clearly it's not going to be this one because it has a 0 as the middle entry. Or neither it's this one, so what's happening here? Okay, I had to double check because it didn't make sense. I think I misread the question. It was 4i, which means that the vector that we are dealing with is 4, 0, minus 5. So if you look at these vectors, actually vector 2a minus 3b is minus 8, 0, 10, and that is minus 2 lots of 4, 0, minus 5. So this one is a multiple of 4i minus 5k. Let's double check the other one. If you look at a vector 4a plus b, which was 12, 14, 20, I would try to maybe make the top number the same, so 4, so we put 3. Take dividing it by 3, you'll get 4 over here. That's going to be 14 over 3. That's 20 over 3. That is not equal to, it's not a multiple of 4, well, it's not 4, 0, minus 5, so it's not equal to 3 lots of 4, 0, minus 5, so not a multiple. Perfect. Okay, let's move along to the next example. So I've done example 6 before, I've done example 5. So the next part that leads to exercise 12b is introducing the way of calculating an angle between two vectors, but one of those vectors is actually along one of the axes. So effectively you're finding an angle, and we denote it with theta with subscript x, with the positive x-axis makes with the given vector. So if you imagine, let's draw a pair your axes. So if you've got a point there with the coordinates a, b, and c, there you go, then the angle that it makes with this this is going to be the right angle, so you drop it to there, and that's the angle that we are looking for. So that's going to be theta x. So it's the angle that the I vector makes with the position vector of point P, is that what we are calculating. So the formula is cos of that angle is equal to x over the length of your vector that you are working with. Okay, so when x is the x coordinate, as you can see, and you can actually extend it to the angle with the positive y-axis, so it's y over cos of that theta y is y over the length of the vector when y is the y coordinate, and similarly with the z-axis. So if you've got to find all three vectors, you need to write the formula cos theta x. Remember, this is going to be x coordinate of the length of vector A. Cos theta y is the y coordinate of the length of the vector A, and cos theta z is z over the length of vector. So let's find the length of that vector. It's 2 squared plus 3 squared plus 1 squared, which is square root of 14. So the first one is going to be x, which is 2 over root 14. Then the next one is minus 3 over root 14. And then you've got minus 1 over root 14. Normally in vectors we are using angle not measured in radians but in degrees. So switch it to degrees. So it's going to be cos inverse of 2 over square root of 14. So that is theta x is equal to cos inverse of 2 over root 14. That gives us the angle 57.7 degrees. The next one is going to be cos inverse of minus 3 over root. So that's an obtuse angle, which is 143.3 degrees. And then the last one, again, is going to be an obtuse angle, which is 105.5 degrees to 1 decimal place. Okay, now we've got 2 points, A and B, so I'd like to sketch them in the next example. I like to write the position vectors of those points vertically next to those points. There you go. And then we are going to first of all find vector AB. So vector B, remember, it's, if imagine that's the origin, so it's vector OB minus vector OA, so it's n minus beginning. Effectively, what do you do to A to get to B? So 4, you go down 1, so it's minus 1, 2 to 4, you're going to add 2, 7 to minus 1, you're going to take away. There you go. So going down to 8. If you want to just check, look, 3, 4, minus 1, subtract 4 to 7. So you've got 3 take away 4 is minus 1, 4 take away 2 is 2, and minus 1 take away 7 is minus 7, so that's correct. So that's vector AB. Now to show that this triangle is isosceles, I'm going to find all sides. Okay, so all sides will be needed, are required. So let's find AB by doing Pythagoras to vector AB. So it's 1 squared, add 2 squared, add 8 squared. So that's going to be 64, add 5, which is square root of 69. Then I'm going to find vector OA and then vector OB. So the length of vector OA is 4 squared, add 2 squared, add 7 squared. So this is going to be 16, and 4 is 20, add 49. That's actually 69. So you could see that it is isosceles. I don't need to check the last one, and we'll just do it just for practice. So that's going to be 9 add 1, so it's 10 add 16, square root of 26. So AB is equal to OA, therefore triangle OAB is isosceles. So these two are the same length. Okay, so now you are ready to start exercise 12b.